Hey guys, okay, so today we're going to work a little further on simplifying the trig expressions. So I kind of want to note one thing. On one of the problems, I believe it's either on the practice test or the test itself, you have cosecant and cotangent on one side of the equal sign. Let me write that down, cosecant and cotangent on one side of the equal sign, and you have cosecant and cotangent on the other side of the equal sign. So in that case, don't change everything to sine and cosine because you already have the same trig functions as what you have on the other side of the equal sign. So leave it alone. Just a little looking ahead hint there. So I wanted to go over what happens when there's nothing you can do further trigonometrically because everything is already in terms of sine and cosine in this first problem. And what happens when also there's nowhere algebraically to go. I can't split up a denominator. By the way, don't ever do that. So there's nothing to do here. I can't factor. There's nothing to multiply. So one thing I wanted to bring to your attention is that sine and cosine do have Pythagorean identity in common, which is squared. So what I'm going to do is, and this is a method you can use when you're pretty much stuck, you multiply the denominator by its conjugate. Remember in Module 2, conjugate means the same exact terms, 1 in cosine, but the opposite operation. So since this one is plus, this one's minus. And I can't just multiply 1 minus cosine to the denominator. I have to keep a fraction balance, so I'm going to do the same thing to the numerator. And we multiply fractions straight across. So for the numerator, I'm just going to bring down sine and then 1 minus cosine that it's being multiplied to. And I'm just going to work on the denominator for now. So working on the denominator, sidebar here, when you FOIL or distribute or multiply conjugates, you can bypass the whole FOIL thing and just do first and last, or what I call Florida, because outer and inner will always multiply to be 0. If you do FOIL, it's fine, you'll get the same answer, but just kind of a little shortcut. So 1 times 1 is 1, and then last, positive cosine times negative cosine is negative cosine squared. And using my Pythagorean identity, which states sine squared plus cosine squared equals to 1. Keep in mind the identities, you can move from one side of the equal sign all day long, but when you verify, don't do it for the actual problem. But the identities have already been proven, so you can always move anything you need from one side of the equal sign to the other. In this case, I'm moving cosine squared to the other side because I want 1 and cosine squared together to find out what it equals to. So sine squared equals 1 minus cosine squared. So because of that, I'm going to replace this 1 minus cosine squared with what it equals to, which is sine squared. The numerator I have not used at all. I'm going to bring down. And anytime you have plus or minus and you're trying to divide out anything, remember this rule. If you can factor it out, you can divide it out. So see the minus sign here? As long as you can factor it out, you can divide it out. So what I'm talking about, and I know I'm throwing a lot at once, but just throwing the algebra out here at once as well, meaning this is not a real thing. You can't cross out x. If you can't factor it out of both terms, you can't divide it out. So we're just going to cross over that. Ew. Okay, so since I can factor sign out, I can divide it out. This sign gets rid of one of these. And this leaves me with 1 minus cosine over sine. Now remember I said you can never split up a denominator, meaning I can't put sine over each one of these denominators, or the terms in the denominator, but I can always split up a numerator. So I can give each one of these terms in the numerator its own denominator of sine. And then you're going to go into your trig identities because you really shouldn't have a trig function left over in the denominator if you don't have to. 1 over sine, if you look under the reciprocal identities, is equal to cosecant. And under the quotient identity, let me make a note of that, reciprocal, and under the quotient identity, you'll see that cosine over sine equals cotangent. And now it's simplified. Hope this helps, guys.